Hey, welcome back, Mastery Algebra 1. This is lesson 7-5, the root of the problem. What we're going to do is we're going to look at rational exponents and how they can actually represent radicals. So how would exponents work if they were fractions? To find out, we will use the internet concept where the base number represents the amount of information that gets multiplied every year. And since the exponent represents time, we will be looking at situations where less than a full year has passed. So the exponent is a fraction. Okay, so if we look at number 1, suppose the amount of information available on the web is multiplied by 4 every year. Hence, if we go back to previous sections, if we had 4 to the first at the end of 1 year, 4 amounts of information. If we were 2 years, we would have 4 times 4, which is 16 units of information. Okay. But what happens if we go half of a year? So realistically, if we know at the end of 1 year we should have 4, and we go half of a year or 6 months, we probably should have 2. So we're going to write 4 to the 1/2. Okay. And then if we go to B, after 2 half years have passed, we're looking at 4 to the 1/2, and then we have another 4 to the 1/2, which makes a full year. So that should give us 4 units, or 4 to the first. Okay, if you remember the rule, b to the m times b to the m, if the bases are the same, we're going to add these exponents. So we have 4 to the 1/2 plus 1/2, which gives us 4 to the first. Okay. So what we're trying to do really is find the missing value. We're trying to think of what's one number that you can multiply by itself and get 4. Right off the top of your head, you're thinking, hopefully, 2 times 2. So therefore, 4 to the 1/2 is really 2. So 2. Suppose that the amount of information on the World Wide Web is multiplied by 9 every year. How much information will be available? So if we look at, again, half of a year from now, we would say 9 to the 1/2. So we go after 2 half years have passed. So again, 6 months, or if we go 9 to the half times 9 to the half, that should be by adding exponents. 1/2 plus 1/2 is 9 to the first. We're trying to think of what one number can we multiply by itself to get 9. Hopefully you're thinking 3 times 3. So 9 to the 1/2, these should be equal. So 9 to the 1/2 should be equal to 3. All right, for 3 and 4, go ahead, hit pause. Do 3A through D. Do 4A through D. And check back in a couple minutes. Go. All right, welcome back. If you check your answers, so if we go a third of the year from now, so we're breaking up the year into 3 parts, and 27 is the multiple every year, we're going to have 27 to the 1/3. So we have to add 27 to the 1/3 times 27 to the 1/3 times 27 to the 1/3 to get 27 to the 1 whole. So if we are adding 1/3 plus 1/3 plus 1/3, we'll get that whole. So what number times itself this time? 3 times to get 27. Hopefully you came up with 3. So 27 to the 1/3 is really 3. Again, on 4, we're at 16 multiplied every year. So 16 to the 4th. We're basically coming down to say, well, what times what times what times what? 4 times is equal to 16, and the answer was 2. Next page. So if we're using the same concept or reasoning to estimate the following, okay, if we take 5a, we're going 16 to the 1/2. We're trying to think of 16 to the 1/2 times 16 to the 1/2, because they're in half years. That should be equal to a whole. Okay. So we're asking ourselves, well, what times what itself twice will equal 16? Hopefully you're thinking 4. So therefore, 16 to the 1/2 should equal 4. If I skip to E, if we're doing 8 to the 1/3, so I want to figure out, well, 8 to the 1/3 times 8 to the 1/3, and because of the 3, we want to get a 1. So we need this to be a full unit or a full year. Okay, so we're going to say, what times what times what 3 times will equal 8. And hopefully you're thinking 2. So therefore, 8 to the 1/3 Bleh. Do not make it look like 8 1/3. So 8 raised to the 1/3 power should equal 2. So go ahead and hit pause. Finish 5 and check back in a couple minutes. Go. Alright, welcome back. If you check out the green, 36 to the 1/2 should have been 6. 216 to the 1/3 should have been, what number times itself 3 times equals 216, which is 6. 49 to the 1/2 was 7. 81 to the 1/2 was 9. 64 to the 1/3 was 4. And 81 to the 1/4 was 3. Alright, number 6. So taking and breaking this down. So the answers in the question should be similar or familiar. So the square root of 16 we know is 4, because 4 times 4 is 16. So remember, with radicals or roots, we're looking for the 2 guys that go to jail and only one gets out. So what times what, or what pair equals that number? Or in this case, if we come over here on the side, we're looking at, we'll call this n. This is called the index. Okay. This is called the radicand, and then we have the radical sign here. So that index lets us know how many we need to get a number out. So with the roots and the index, okay, this number, if there's no number that appears here, okay, we're going to assume that that's a 2, so square root. So there's a square root here, 2, now there's a 3, so now we're looking at the cube root. So if the square root of 36 is 6, because 6 times 6 is 36. The cube root of 8 is 2, because 2 times 2 times 2 is 8. B. 49 square root is 7, because 7 times 7 is 49. And the square root of 81 is 9, because 9 times 9 was equal to 81. F. Cube root of 64, we're thinking 4, because 4 times 4 times 4 is equal to 64. And G, the answer was 6, because 6 times 6 times 6 was 216. And the fourth root of 81 was 3, because 3 times 3 times 3 times 3 was 81. So hopefully you're making the connection between fractional exponents. So this rule suggests that the denominator of fraction exponent indicates a root. So when we have b to the 1/2, this 1 is the exponent on the b, and the 2 indicates this index or root. So we're looking at the square root of b. So when it's b to the 1/3, we're looking at the cube root of b. And in general, if it's b to the 1 over n, this n again is the index. Okay? So the same would apply if we had a number. If we had 8 to the 1/3, we're looking at 8 to the 1st, and then we're taking that cube root of 8. Okay? So using this rule, we're going to evaluate each of the following. So A, 25 to the 1/2 is the square root of 25, which is 5 times 5, therefore the answer is 5. Okay? Or 100 to the 1/2 we can rewrite as the square root of 100, which is 10. 216 to the 1/3 is the cube root of 216, or 6. And 256, the fourth root of 256. I think what times what 4 times? Well, 16 times 16 is 256, but that's only 2. So if we broke the 16s down, we have 4 times 4 times 4 times 4. Therefore, the answer is 4. Okay. Go ahead and hit pause. Finish up number 7. And then in 8, you're going to use the rule in reverse to find out the blank in each problem. Go.
How long is it usually before you go back and edit?
All right, welcome back. If we look at 7b, d, f, and h, again, 100 to the 1/2 should have been 10. 125 to the 1/3 was 5, 81 to the 1/4 was 3, and 32 to the 1/5 was 2. Going backwards a little hard on 8. So we start with 8a. If you have 8, and we were taking the square root of something, so it's really, you need 2 of those to get 8. So 8 times 8 was 64. So we were really starting with the square root of 64. Okay, how can we rewrite that as an exponential? Where it is taking it 64 to the 1/2. So the square root and 64 was to the 1. Okay, 15 was 15 times 15, or the square root of 225, which is 225 to the 1/2. E, if we were taking the cube root of 5 times 5 times 5, which is really 125 cubed, that was 125 to the 1/3. And 6, when we were taking the 4th root of something, it was 1296 to the 1/4. And B, D, F, and H, you can check your answers as well. All right, next page. So if we look at the root of the power continued, in this activity we will continue to explore fraction as exponents. In particular, we want to learn to find the value of expressions like 4 to the 3/2 and 8 to the 2/3. So when our index is still a number like 2 and 3, but now if we are using our exponents, instead of a 1 on top, like 4 to the 1/2, we're going to take a 3 or a 2. Okay. So first, let's practice using some exponent rules we have already learned back in 7.3. Okay, if we had 2 to the 4th raised to the 3rd power, this was really 2 to the 4th 3 times, 2 to the 4th, 2 to the 4th, 2 to the 4th, which was the easy way of saying 2 to the 4 plus 4 plus 4, or shortcut, 2 to the 4 times 3. So 2 to the 12th. Okay. So D, 2 to the 3rd to the 4th power, is the same as 2 to the 3rd times 4, or 2 to the 12th as well. Okay. B, 3 to the 5th raised to the 2nd, is again 3 to the 5th twice, or 5 times 2, which is 10. So this is 3 to the 10th. E, we have 3 squared times 5, which is 3 to the 10th. 5 squared times 4, which is 5 to the 8th. And 5 to the 4th times 2, because we have 5 to the 4th twice. This means 5 to the 8th. Okay. So now if we apply some fractional exponents, we're going to apply the same rule with multiplication. So 4 to the 1/2 raised to the 3rd power is the same as 4 to the 1/2 times 4 to the 1/2 times 4 to the 1/2. Or if we add the exponents 1/2 plus 1/2 plus 1/2, we end up getting 3/2. Okay? Or it's the same as if we were to take 4 to the 1/2 times 3 over 1. Okay? So D, 4 to the 3rd raised to the 1/2, should be 4 to the 3/2. B, 4 to the 1/2 raised to the 5th power, should be 1/2 times 5, should be 5/2. 4 to the 5th times 1/2 is again 4 to the 5/2. 4 to the 1/2 to the 7th is 4 to the 7/2. And 4 to the 7 should be, or to the 1/2 should be 4 again to the 7/2. Make sure on each of these also that your numbers do not look like 4 and 7/2, that they actually look like 4 raised to the 7/2. Okay. So summarizing what we actually did, what are we doing here? Often exponents can be thought of as having 2 parts, done separately in either order. Okay. So 4 through 7, we're going to think about expressions again, 4 to the 3/2 and 8 to the 2/3. So in the expression 4 to the 3/2, the base number 4 means that the amount of information available on the internet gets multiplied by 4 every year. Okay. So what does the exponent 3/2 mean? It means it gets multiplied by 4 every 1.5 years, or 3/2 years. In a fractional exponent like 3/2, the denominator indicates a root, which is what we did before, So this 2 is the root. So we need to find the square root of the base, or the square root of 4, which is really 2. Okay. So this means that 4 to the 1/2 is 2. So we should multiply by 2 for every 1/2 year. But since we want 3/2 years, or 1.5 years, let's just multiply by 2 3 times. So 2 times 2 times 2, which equals 8. Therefore, 4 to the 3/2 is equal to 8. So another way we're looking at this is we have 4 to the 1/2, and we just bring the 3 out. So 4 to the 1/2 times 3 is really 4 to the 3/2. Okay? So what we did, if we remember back before, 4 to the 1/2 is really the square root of 4, which was 2. So therefore we have 2 to the 3rd, which is what we did here. Okay? So 6 in the expression 8 to the 2/3, explain the meaning of the base 8 and the exponent 2/3. What we're saying is, okay, if we just take this as 8 to the 1/3 and bring out this 2, okay, we're really saying 8 to the 1/3 times 8 to the 1/3 times 8 to the 1/3 will give you a whole of 8. Okay? Or we're trying to figure out what times what 3 times gives us a 8. Okay? Or another way is looking at, well, what is the cube of 8? And the cube of 8 is 2. Okay? But we still have that exponent of 2 on the outside, so we're going to square the 2. So 2 times 2, which is 4. Okay? So we need to multiply 8 every year for 2/3 of a year. So last one, number 7. If we're going to find the root indicated by the denominator of the fraction, the cube root of 8 is equal to 2. Now we multiply this by a number indicated by the numerator, 2 squared, which is 2 times 2, which is 4. Therefore, 8 to the 3/3 equals 4. All right, number 8. Let's put all these ideas together involving the fractional exponents and then look at rule number 2. So 4 to the 1/2, we're thinking the square root of 4, which is 2. Okay. C, 4 to the 5/2. Well, another way of writing that is bring that 5 on the outside. 4 to the 1/2 to the 5th power. So 4, or the square root of 4, or 4 to the 1/2, we know is 2. So 2 to the 5th is 32. Going back to the ones before, 27 to the 1/3, we should know is 3 times 3 times 3. So 3. So we can look at as 27 to the 1/3, well, we know is 3. And 3 to the 4th then is 81. So what we just did was 27 to the 4/3 is 81. B, 4 to the 3/2 is really equal to 4 to the 1/2 to the 3rd, which is the same as 2 to the 3rd. So 2 times 2 times 2 is 8. Okay. D, 4 to the 7/2 is the same as 4 to the 1/2 raised to the 7th power. So now we have 2 to the 7th, which is 2 times 2, 7 times, or 128. And F, 27 to the 2/3 is the same as, if we bring that 2 out, 27 to the 1/3, which is 3. 3 squared is 9. And 27 to the 1/3 is 3, but we go 3 to the 5th, which is 243. Okay. So fractional exponents rule. B, we'll just use in variables to confuse you. Okay. This m gets pulled out. Okay. The top number, so this is b, this is your exponent, and the bottom, remember, is your root. Okay. So b to the 1 over n raised to the m, or you can actually reverse this and say b to the m first raised to the 1 over n. So using what we just learned, we're going to apply those principles to number 9. Let's look at A and D, and then we'll let you accomplish these on your own. Okay, so for 9A, let's rewrite. Okay, 4 to the 3/2 is really 4 to the 1/2 to the third. So we're looking at the square root of 4 raised to the third power. The square root of 4 is 2, so 2 to the third is 8. Okay. Another way of looking at it, remember, 2 is the exponent, 3 is the root. So let's do the cube root of 27 first. And then we can square it. So the cube root of 27 is 3, and then 3 squared is 9. Much easier. Go ahead, hit pause. Finish all the way through O. Check back in a couple minutes for your answers. Go. All right, welcome back. Be sure to check your answers. Be sure to check with us and see if you have any questions. Congratulations, that's 7-5. Remember, do your best, forget the rest. Bye for now. Now.